Okay, in this video I'll go through something called the chain rule in differentiation. Okay, so let's take this example. Let's say we have y equals 3x plus 7 to the power 6, and we want to find what dy over dx is. Find dy over dx. Now one thing you can do is you can of course expand this bracket. You can expand it using binomial expansion, but that would take a very long time. So it's nice to have a very quick way of doing this. What we can do is, like, we can say that let this bracket here, whatever is inside, the terms inside this bracket, I'll say, let's call that t. So which means I could say t is equal to 3x plus 7. And if t is equal to 3x plus 7, I could rewrite y in this form. I could say y is equal to t to the power 6. Because t is equal to whatever is in here. T is equal to 3x plus 7. So instead of raising 3x plus 7 to the power 6, I could say let's raise t to the power 6. Now let's try and differentiate these two functions. So now if we have y and a function of x, we usually get dy over dx. In this case, let's differentiate t with respect to x. So what I get is dt over dx. So dt over dx, differentiating the right hand side, we've seen that the derivative of 3x plus 7, that would just give 3. And similarly, I can say that dy over dt will be equal to, now I'm differentiating this with respect to t. So just bring the power to the front, so I have 6 times t, reduce the power by 1, so I have 6t to the power 5. Now what I've got here is I've got an expression for dt over dx, I've got an expression for dy over dt. So somehow I'm going to use these two to find an expression for dy over dx. And here's what I'll do. Let's say dy over dx, let's say that's equal to, and I'll rewrite it like this. So I'll say dy over something times some other variable over dx, or the way I think of it is just move the dx, instead of writing dy over dx, just move the dx over here. And in these spaces, since my variable is t, let's put dt and dt. And if you didn't already know, dy and dx, you can treat them like variable, you can treat them like fractions, dy over dt. And dy, dt and dx can be treated like variables where you can cancel them off. So on the right hand side here, I could cancel off dt and dt, and I would get dy over dx, which is the same as what's on the left hand side. And this rule here, I mean, this here is really what the chain rule is. And in this case, I've only chained, you can say I've linked two different derivatives, but you can link as many as you want depending on how many variables you have. But this is the main formula. You can think of this as the main formula for the chain rule, which is quite useful to remember. So I could say that dy over dx, what is it equal to? Now dy over dt, I've got dy over dt is equal to this. So I have dy over dt is equal to 6t to the power 5 times dt over dx. dt over dx is equal to 3, so that's times 3. So this gives 6 times 3 is 18, 18t to the power 5. Now remember, our equation was given, or our function y was given in terms of x and not in terms of t. So and t is a variable that I just introduced. So I have to put all of this back into terms of x. So I can say instead of 18t to the power 5, I can rewrite this as 18 times, instead of t, I'll replace that with 3x plus 7. So I have 18 times 3x plus 7 to the power 5. And that will be dy over dx.